how the memory is allocated for the main program. We studied that. Then we studied about processes, Unix process terminations. Till now we have just shut down our systems, we just closed the program and all. But how actually it happens at the back end is what we studied under Unix process termination. Various ways are normal termination and abnormal termination. In normal we have by calling return, which writes to the operating system, by calling exit, which does some cleanup processing like releasing memory, resources, IO devices, then writes to the kernel. And there is another function as calling underscore exit, which will directly write to the kernel without releasing the resources. And the cleaning up process is done by the kernel. This was all about normal. In abnormal, we had abort function and signals. Abort is nothing but when your program is in a panic state, it doesn't remember what to do and what has to be done. You always use a system called abort. I'll show this in the programming later on down the line when we'll go for the programming part. Abort. So abort, whenever you abort it, that is what. See, if your system is not performing correctly, what you do is you just close it. Windows not responding, you just close it. So once you get a restore, you get a file there. Because of this reason, the system file collapsed and all, right? So that is nothing but a log file. Similarly, in Unix also, there is a concept known as abort function. So whenever abort function is executed, Unix generates a cease file. A cease file is nothing but again a log file, which will give the details. What was the reason the program was in panic state? What was the reason the program was not executing? How it can be executed? That like the debugging concept, it gives that. Okay. Then we have signals. Signals are nothing but the software interrupts, which we don't know when they'll occur. See, you're doing something, you're doing some bank transaction, suddenly an antivirus pop-up comes into picture. It's a signal now which is stopping your transaction, right? We don't know when it will occur. You have updated something, suddenly a pop-up window come in front of you. Or interrupt, right? So interrupts are nothing but, signals are nothing but the software interrupts, and they can be stopped by the system called kill. Now kill we can study in the 4th unit. We have all that signals in 4th unit. That is what we studied under process termination. Then we studied about environment list. Now environment list is nothing but it contains a predefined variables which are already defined to the kernel, and those variables are stored in a list known as environment list. We can get the details of the environment list by passing an extra argument to the main function, and that is nothing but env, argc, number of arguments, argv, pointers to the argument, and env is nothing but the environment list. So from that I can get the different environment variables in my system. We saw that how many environment variables are in the system. Then we said with environ. Environ is a global variable similar to env only, but just a different variation of it. That is what I mean to say. That also will give me the list of environment variables. Then it may so happen that you are only interested in one variable. That time we can use a system called get env, where I can pass a single argument to that. And that argument is nothing but the environment variable. Yeah. So this is what we studied under that. Then we studied about memory layout of a C program. Yeah. A very interesting way, and this is what will get you good marks in the exams also, and will help you to understand in your technical skills also. Okay. So whenever we write a program, a block of memory is allocated to a C program. But again, in that block, for each statement, the memory is divided into segments, and those segments are nothing but the various segments. Please remember, from the lower address, the text segment is nothing but where all machine instructions are executed. CC, filename.c, GCC, the compiler copy, the editor copy, a single copy is maintained in the memory, and that is nothing but it comes from the text segment. Initialize segment is a segment where the variables are predefined, declared and defined. Just like here now, int a equal to 5, it is declared as well as defined 5. So it is initialized. So in initialized segment, there are two types: initialized read segment and initialized read write segment. So if I declare a variable with a prefix with constant, outside the main. Okay, please remember it is outside the main. So outside the main, if you declare it, what happens is, for it, the memory is allocated from this initialized segment. This is one block. In block again there are various segments. So for this it is allocated from initialized read segment, because the value of 5 cannot be changed. Similarly, uninitialized segment, data segment is nothing but this segment. The memory is allocated to all the variables which are just declared but not defined. See, int b, int data of 10, you are just declared, they are not defined. So for that, memory is allocated from the uninitialized segment. It is usually called as block started by symbols. Then we have heap segment. Heap segment is nothing but, yes, heap segment is nothing but a pool of memory, which Varun told initially. Stack. It is stack only, but we have just bifurcated it. So whenever you have memory allocation statements like malloc, calloc, realloc, free and all, free means again it goes back to the heap segment. Free, we know, free is deallocate the memory. When it is deallocated, again the memory should go back to the heap segment. So the memory dynamic memory allocation statements, for them memory is allocated from the heap segment, and the variables inside the menu int x, it is just declared, not defined. So what happens? The variables which are declared in the main, for them the memory is allocated from the stack segment. Now what is the stack segment? It is a part of heap segment, which allocates, reallocates, deallocates, updates and all. So every time the memories keep on updating for you. So all those variables which are just declared inside the main, for them the memory is allocated from the stack segment. And there is the higher address is nothing but the command line argument and environment variables. So if at all you have command line arguments or environment variables, for them the memory is allocated from the topmost block. That is what I mean to say. See, this is one block where this see here, this entire program from here till here. Now see, this entire program memory is allocated from block number 3. But how this block number 3 is divided is in this way. Is in this way. Yeah. I hope this is clear now. Okay, we'll move ahead. Okay. Okay, memory out of C program we have studied. Next is memory allocation. That is what now, which again a brush up what we did in data structures. There are various ways of memory allocation at runtime. So at runtime we can allocate memory malloc, calloc or realloc functions. Now what does malloc do? Malloc allocates a specified number of bytes of memory. The initial value of the memory is intermediate, like means this is what I meant to say here. Now malloc allocates for this, at runtime it allocates 50 bytes of memory. So dynamic memory allocation has 3 ways. One is malloc, next one is calloc, and third one is realloc. Okay. So what does malloc do here is, malloc will allocate the memory, the dynamic memory from the heap. Now all this memory allocation statements, memory are allocated from the heap. If malloc does the same thing, then what does calloc do? It allocates a space for specified number of objects of specified size from the heap. See, malloc will allocate only for one object, whereas calloc will allocate for specified number of objects. I guess I have written here. I'll come here. See it. Malloc allocates specified number of size for a single object, whereas calloc will allocate the number of size for specific number of objects. You can specify the number of objects here. This will allocate only for a single object, but this will allocate for the specified number of objects. So that is what malloc will allocate number of bytes for a single variable, whereas calloc will allocate for number of objects. But what is a realloc? Realloc will either increase or decrease the value of previously allocated area. So when the size increases, it may involve like previously allocated area somewhere else to provide an additional room at the end. And when the size increases, the initial value of the space between the old content and the new area is intermediate. Okay. Now look at this when I'm talking about a realloc. Again, I'll come back here. I'll show you this example with a live example. Okay, so we are here now. I'll just use this. We'll come here. Okay, now see. This is a memory block. This is a memory block. This is a memory block. Okay, so these memory blocks are fixed, and this memory block keeps on increasing like this. Okay, I'll show you. Okay, or else I'll do one thing. Okay, I'll just show in the either way. Okay, I'll draw the memory block like this. This I'll take it. Okay, now see. These are the memory blocks for me now. Help me to understand. Okay, what does malloc do? Malloc allocates specified size for a single object. Calloc will allocate for number of objects, specified number of objects, the size. Okay. Now realloc. See, realloc is very important. What does realloc do is, for example, now look at this. Now this block is here, block number 1, block number 2, block number 3, block number 4. Now reallocate means two ways. Either you can increase the memory or you can decrease the memory. So when you are increasing the memory, what happens here? You see, since the memory block is fixed, yeah, the memory block is fixed, and if you want to reallocate extra memory for this, but since this block size is fixed, you can't reallocate it here, you can't increase it here, because beside this again there is next memory block. If you push this line here, the data of this memory block may be lost, right? So for deloading is no problem, because this is the maximum size, you can reduce it. But if I want to increase it, since this memory block size is fixed, I can't increase it here. So what it does is, that is what is said here. See, realloc when increase or decrease the size of previously allocated area. When the size increases, it may involve moving the previously allocated area somewhere else. Please read this statement, okay? When the size increases, it may involve moving the previously allocated area somewhere else. Now what it means here, if you look at this. Now this was already allocated for me. I want to increase the size of block 2, but I can't increase it here. So what it does is, it gives a pointer and it allocates somewhere else where it is free. So again, this is nothing but the additional memory of block 2. Again, wherever it is free, okay? So for 4, I want to allocate extra memory, reallocate. So beside this, maybe this is full. So what I'll do is, for this, somewhere else, wherever it is free, it comes here, and this becomes the extra block for the 4th memory. That is, now for 4th, I'm reallocating extra memory, but I can't do it beside this because this is already occupied. So let's say this example 6 now. Now for 6, I want to reallocate extra block. Now since this block is free, I can reallocate it here itself. But look at this part. For 2, I can't reallocate in the next block because the next block is already occupied by 3rd. So it goes and finds a location which is free in the memory and gives a pointer from here to here. That means for this block, additional memory is allocated into this block. Similarly for the other block, and so on. So that is what I mean to say, how the realloc works. See, realloc pointer, the new size. Pointer is nothing but the new block pointer to which block it is representing, and the new size, how much size you are working it out. So on success, it returns a not null pointer. So please remember, malloc allocates memory for a single object of specific size. Calloc allocates memory for number of objects of specific size. Whereas realloc, you can either increase or decrease. When you decrease the memory, no issues. But when you increase the memory, it sees the size of the block. If the size is already full, it allocates somewhere else, as said here, and this gives a pointer here. It contains a pointer here, a pointer and the new block size. So from here, the additional memory for second block is kept here. This is all about memory allocation. If they ask, explain the different ways of dynamic memory allocation. The different ways are malloc. Dynamic memory allocation is nothing but a concept where memory for C program is allocated at the runtime. How it can be allocated? In three ways: malloc, calloc, and realloc. Malloc is nothing but specific size of object for a specific size of memory for a single object at runtime. Calloc, specific size of memory for number of objects. The number of objects is specified 3, 4, 5. And realloc is either used to increase or decrease the memory of the previously allocated block. Decrease is not a problem, but when you want to increase the memory, if the beside block is already occupied, it assigns to a new location. That is what it said here. Again, I'm repeating it. When the size increases, it may involve moving the previously allocated area somewhere else to provide additional room at the end. So somewhere else. And when the size increases, the initial value of the space between the old content and the new area is intermediate. So it is in between somewhere. Okay. So this is all about memory allocation. Clear with this? Okay. This was about memory allocation. Again, that is what alloca. Alloca is again an extra function, just like malloc, calloc, and realloc. Alloca is also a different function. The only difference here is alloca is similar to malloc only. That is, it allocates the specified size of memory for a single block. The only difference between malloc and alloca is, for malloc, the memory is allocated from the heap. But for alloca, the memory is allocated from the stack frame of the current function. If alloca is called in main function, it is allocated memory from the stack frame of the main function. If alloca is called in UDF, that is user defined function, it is memory is allocated from the stack frame of the user defined function. That is the only difference over here. Then what's the advantage? The advantage is that we don't have to free the space. So in malloc, once we allocate, we have to use a system called free to free the memory space. But if you use alloca, the only difference here is, see, remember, okay, there are two differences. Alloca is similar as malloc. It allocates specified amount of memory for a single block. Alloca, for malloc, the memory is allocated from the heap segment, whereas for alloca, the memory is allocated from the stack segment. Again, going back here, see, for malloc, the memory is allocated from the heap segment, but whereas for alloca, the memory is allocated from the stack segment. Now, what's the difference? If the memory is allocated from the heap segment, we need to free the memory explicitly also. Only use the system called free. But if alloca is used, in alloca, the memory is allocated from the stack segment. So since the memory is allocated from the stack segment, we don't have to free the memory explicitly. Once the system call is done, it automatically deallocates the memory. Then what are the disadvantages? The disadvantage of alloca is some systems, that is some versions of Unix, don't support alloca. Because, as I said, in Unix, memory is very strict. The best example of this is segmentation fault you get, right? In Windows, we never get a segmentation fault, but in Unix, we get segmentation fault. Why is that? Because memory is very strict in Unix, right? So in some systems, it is very difficult, or they're difficult that they support alloca because memory is very strict and you can't change the size of the stack frame and all. So in the memory allocation, there are three types: malloc, calloc, and realloc. Apart from that, there is one more known as alloca. Alloca is same as malloc, but only difference is the memory is allocated from the stack frame. You don't have to free the memory explicitly. Automatically it goes when the system call is terminated. And the disadvantage is not all systems support alloca. Okay. Next is environment variables. That is what we studied now. Okay. We said environment variables, home and all. We know now environment variable is nothing but it is a value to a variable which is predefined by the system. Just like when I say home, it will tell me which is the home directory. Please don't get confused with environment list now. Okay. Environment list is nothing but a list which stores environment variables. A list which stores environment variables is nothing but an environment list. And what is an environment variable? It is a variable whose value is predefined to the system. Okay, this is also I know now. Now, environment variables are nothing but they're of type string, which will tell me what value is assigned to each variable. Now we studied home, which will tell me which is the home directory. We have PWT, which will tell me the present working directory. It will tell me the shell, which shell I'm using. It will tell you the log name, all that. All these are the environment variables. So here, if at all you want to get the value of a single environment variables, you can get it by the system called getEnv. That is what we said in the previous statements. GetEnv and the variable name figure, it will display the value assigned to this variable. So it is said that the environment strings are usually of the form name equal to value. The name is nothing but the name of the environment variable, and value is nothing but the value assigned to this variable by the system. Now for home, maybe the value assigned is home/Sayed. That means from this directory, this is the value assigned to this home variable. Now there are various ways. Now you being a good programmer, right? There are n number of ways where you can get the value of an environment variable. You can set a new value to the environment variables, or you can put new environment variables. See, if you're as I said, my system had almost 32 environment variables. You can even get the value of environment variable by the system called getEnv. Now, whenever I log into my system, it shows the name as user1, user2. Home directory is user1. Now I want to give it my name for that. If at all you want to do it, you can always do it by the system called setEnv. But this all has to be done at the admin mode. Okay, please remember. At the root level, you should have root level privileges to do all these experiments there. You can always change the value of environment variables. That can be done by the system called setEnv. SetEnv system call is used to set a new value to the environment variables. For example, now see, if this is the old value, I'm going to say here, I want to give it new value. So I can do that, home equal to /home/ I say like this. Now this new value I want to give my home directory. That can be done by using the system called setEnv. And next one is putEnv. PutEnv is nothing but if at all you want to add a new variables. That is what I said. If you're a good high coder and you have to add your own environment variables, so I don't have to code again later on. So once you do it, you'll get the values. So for that time, you can always add new environment variables to the system by the system called putEnv. So environment variables, you can get the details by the system called getEnv. You can change the details by the system called setEnv, and you can add new environment variables by the system called putEnv. That is what's here. PutEnv character string. So what it means is, so whatever the string you give here, that value will be added to a specific environment variable, or that environment variable will be added to the list. setEnv name, rewrite name. So for which variable you want to add a new value, that can be got by the system called setEnv. So this sample program I will tell in the next class. Okay, I have the code written for them. In Fedora, I'll just tell you how you can add a variable. You can, because since I'm working on a Ubuntu here, virtual machine, difficult for me to do that. You should have a system where you're working on that, because in virtual machine it will not allow me to do that. So setEnv will set the existing value to a new value. PutEnv will add a new environment variable to the list. Okay, that is what setEnv again. If name already exists in the environment list, then it rewrites. If not, it replaces with the new value. So in the exams, please remember they can ask, explain environment variables and environment list and different ways of fetching the environment variables. So in that case, what are environment variables? These are the variables whose values are predefined in the system and stored in a list known as environment list. Environment list can be got in three ways. One by a variable by passing the third argument env, by the global variable environ, and third one is by the getEnv. You can also change the values of the environment variable. You can also add the new values to the environment variables. But all this has to be done with the root privileges. We can add new values, or you can add new environment variables by the system called putEnv. And you can change the values of the environment variables by the system called setEnv. and unset is will remove again. Same thing like when malloc will allocate, free will release the memory. Similarly, unset, just like in Windows and all, you always go right. You make some changes, some theme and all you upload in your mobile phone. You just do all those changes, but later on it is not looking good. And what you do at that time, you say default setting. So the minute you click on default setting, it comes back to its original value. Same thing is unset env here. Unset will remove all the definitions which you have changed it and keeps it to the initial system only. Okay, is this clear? I can come back here. Is this clear now? Everyone, what we studied now? Yeah, we said about environment variables. Okay, please remember that. Okay, it should not confuse this. So set and yes, Abhishek, set and put. Which set and which put you are talking here now, Abhishek? Set env and put env. Set env will set a new value to the existing environment variables. For example, you have a laptop at your place, your brother is using that, okay, and he has his home directory already given there. So all time when it runs, it shows your brother's home directory. So if at all you want to change it to your directory by your name, you can use set env. Set env will set a value to the new value to the existing environment variable. Now put env will add a new string. Put env will add a new string to your environment variable. For example, if there are 5 environment variables, you want to add one more known as terminal. If at all you want to add one more variable terminal, you want to add one more environment variable mailbox, set mail, put mail and all, that time you can use put env. Put env is to add new values, whereas set env is used to change the existing values. Is this clear? The set difference and set jump and long jump I'll take in the next class. Okay, why? Because I require some concepts there to be told, and within 45 minutes, 10-15 minutes, I can't do that. So better I'll keep it for the next class, which is, as Varun said in the group now, tomorrow 10 o'clock. Okay. I hope you got. Please don't leave it. I have a quiz to be. You have a quiz to be answered. Okay. See, any doubts, you are free to ask me. Okay. You have any doubts at any time, you are free to ask me the doubts. Now this is the attendance for the session 2. Okay, please do this. Okay, got it for the 3rd chapter. The portion for the first I is first 2 units. Okay, probably sirs, other sirs will. That is what we discussed at our level. It is first 2 units from the syllabus portion, and the notes, people were asking me about the notes which I had shared in the class. Please make sure that those notes are just the contents which I dictated, I kept for my level. Some notes are not there, so please don't depend on that. The things which are not there in the notes, you are always free to refer the textbook. Okay, yes, no doubts then. Okay, then shall we close it? If no doubts, we'll close the class then. Because the next concept I require some time to, 1 hour I require, set jump and long jump for the next class. Okay, Akshay is left. Okay, shall we stop it? Anybody in the chat box for me? Yes, Abhishek. Okay. Okay. Thank you then. Okay. See, my numbers are also available in your class group. Okay. Please feel free to ask any doubts anytime. No issues in that. Okay. Don't hesitate that, sir, I did not understand, because since we are going with the distance learning concept, it is not happening as good as we did for our DBMS, right? Yeah. So since the distance learning, you are free to ask me. I'll try to cover as much as